For completeness, we're going to introduce you to one more operation, and that is a row times a matrix multiply. So we've seen matrix vector multiply, we've seen rank 1 updates, now we see row times a matrix multiply. So what if we want to update Y transpose, a row, by multiplying a vector X times a matrix A and adding that to the row vector Y? Sort of looks like a matrix vector multiply, but it's a little bit different. Again, what do we do these days? We slice and dice. How do we like to slice and dice first? Well, we know that accessing matrices by columns is a good idea. So let's take our matrix A and let's partition it into its columns. And, well, if we leave X alone, then we end up doing dot products of X with the columns of A. That's good. But what that means is that we need to partition Y into elements. It's a row. And we need to add that to psi 0, psi 1 through psi n minus 1. And what do we get now? One thing that you should have noticed by now is that this kind of multiplication works just as if this were a number, say 2, and these were minus 1, 5, 3. Then you would know to do this times that for the first entry, this times that for the second entry, this times that for the third entry, right? 2 times the first entry, 2 times the second entry, 2 times the third entry. So that works exactly the same way, except now we do it with symbols and we have to make sure that sizes match up. So this here becomes X transpose times A0, the dot product of X with A0 for the first entry, the dot product with the second column for the second entry, and so forth, which must be added to psi 0, psi 1 through psi n minus 1. And then we see that that's just a matter of now adding corresponding entries there. So we get that you need to do the dot product of X with the first column and add that to the first element, the dot product of X with the second column, adding to the second element, and so forth.